Hi, this is presenter Gi-ho. I will start the presentation of third week of Group 2. This week announcement is as follows. Here the Gantt chart. Last week we simply finished sketching the product and this week started mechanical analysis of the actual products. We tried to design a device that can be used without bending for hair salons or factories where used truly often. Next, I have collected important questions from the last presentation and here it is. Problems caused by the different movement of first and third tray. Which motor we will need? Won't it be more expensive than the existing trolley? A risk of spilling a tray. According to the last design, when third tray come up, we won't use first tray, and we have to put on a new device to close them completely. For this reason, we decide to change the way it works a little bit. The new way to operate is that the tray comes out of the side, not the front. So, how should we design it? First, we track the appropriate expected size according to the user. Next, we conducted load analysis through this temporary size and decided the final size, and finally we selected motor based on load analysis. The worker standing posture can cause health problems. We use cautious data to find a good working height. In addition, we have to consider a distance that user can reach without movement to pick up the items. Referring to the statistics of Korea and news, we came to the conclusion that 85-90 heights are good to use for workstations. We will show you how to move. And this is the size and image of products.
Hi, I'm Park Jun-sung. I will explain the model required for horizontal motion. For the material of tray, we will use polypropylene, which is the most common and has good rigidity. It is also economical material. In horizontal motion, we have to consider the load and the friction force of tray. Investigated friction coefficient of polypropylene was 0.3, but we kept in mind that the friction coefficient depends on the shape of the product, even if the same materials are used. So the investigated value 0.3 were used in calculation, but the exact coefficient will be obtained through a final test in the future. Then, we did torque calculation for motor selection. The necessary variables are here. Road moment of inertia, acceleration torque, and friction load torque must be obtained. By substituting the weight, constant rotational speed of the motor, and the time for the motor to accelerate, we can obtain the needed value. Calculation gives the required torque for acceleration as 15.45 kg/cm. Since the required torque value is higher than expected, we decide to use gear ratio effect. Considering the error in the friction coefficient, arm length, and the motor, safety factor is set to 1.5 and gear ratio is 3:1, and gear efficiency is 60%. Then, torque is reduced to 4.64 kg/cm. A motor with a torque of 5.304 kg/cm that can safely withstand this torque value was obtained and selected to be installed. Thank you for listening.